There's a mountain in the Chilean desert where, for the first time in human history, machines began watching the sky closely enough to catch the universe changing in real time. And on one night in February 2026, that mountain sent out 800,000 warnings in a single sitting. Not warnings of danger. Warnings of something stranger. Somewhere in that flood of signals sits an object spinning so fast it should not exist. A star that vanished instead of exploding, and a visitor from another star system that slipped past Earth before anyone even knew to look for it. What if the most important discovery of this decade has already happened, and almost nobody has noticed yet? For most of history, looking at the sky meant looking at a single frozen frame. A telescope pointed at one patch of darkness, captured one photograph, and astronomers spent months, sometimes years, deciding what that photograph meant. That was the entire model of discovery for 400 years. You wait, you point, you capture, you analyze. The universe was treated like a painting hanging in a gallery. Static, fixed, safe to study at leisure. But paintings do not explode. Paintings do not spin. Paintings do not arrive uninvited from other solar systems and vanish again before you can turn around. The universe was never actually still. We were just too slow to catch it moving. And on a mountain called Cerro Pachon, at 8,800 feet above sea level in northern Chile, that 400-year assumption quietly ended. The facility responsible is the Vera C. Rubin Observatory, an $800 million instrument jointly built by the United States National Science Foundation and the Department of Energy. And, at its heart, sits something that sounds almost fictional. The largest digital camera ever constructed by human beings. It weighs about 3,000 kilograms. Its resolution is measured in the thousands of megapixels, 3,200 of them to be exact, which means a single photograph from this machine would require hundreds of ultra-high-definition television screens standing side by side just to display it at full size. Think about what that means for a second. Not a phone camera, not a professional camera. A single image so enormous that no room in your house could hold enough monitors to show it to you properly. And this camera is not built to sit still and stare. It is built to move, to scan, to sweep across the entire visible sky, again and again for 10 straight years. The telescope carries the name of Vera Rubin, an astronomer who, in the 1970s, did something that quietly rewrote the rulebook of physics. She studied how galaxies rotate and found that the outer stars were spinning far too fast for the visible matter holding them together. According to the laws of gravity as they were understood, those galaxies should have flown apart. They didn't. Something invisible was holding them in place. Mass that gave off no light, betrayed no signature, and yet outweighed everything we could actually see. She had just found the first hard evidence for dark matter, one of the greatest unsolved mysteries in all of science, and half a century later, an entire observatory now bears her name with a singular mission: catch the universe in the act of hiding things. The project itself carries a title that sounds almost like a warning: The Legacy Survey of Space and Time. Officially begun on July the 1st, 2026, after years of delay while engineers quietly, carefully verified that every system was ready, this survey is designed to do something no telescope has ever attempted. Every 3 to 4 nights, it will photograph the entire visible southern sky in its totality. Every 40 seconds during a night of observation, the telescope shifts to a new patch of darkness and takes another exposure. Over 10 years, this creates something scientists are calling the largest time-lapse movie of the universe ever assembled. Not a photograph, a movie. A decade-long, continuously updating record of everything in the sky that moves, brightens, dims, appears, or disappears. And once you understand that distinction, the real story starts to come into focus. This was never just a telescope. It is a surveillance system for the cosmos, and it has already started catching things nobody expected to see. The first hint of what was coming arrived in June 2025, before the main survey had even formally begun. Scientists released what they called a preview. A handful of nights of test observations pointed at a region containing the Virgo cluster, a dense knot of galaxies relatively close to our own. In that short window, the observatory captured more than 10 million galaxies, many of which had never been cataloged by any instrument before. 10 million, not stars, galaxies. Collections of billions of stars each sitting invisible in the dark until this camera opened its eye toward them. And almost as an afterthought, buried in the same data, the telescope quietly discovered 2,000 previously unknown asteroids in our own solar system, objects that had been drifting past Earth's cosmic backyard, completely undetected until a test run of a machine that hadn't even officially started working yet. But here's where it gets worse. That was supposed to be the calm before the real survey. The actual test of the alert system, the part of the observatory designed to notify astronomers the instant something changes in the sky, didn't happen until February 24th, 2026. On that single night, photographing a patch of sky where earlier surveys had already built a reference template, the observatory issued 800,000 alerts in one night. Each alert represented something that had changed, appeared, or vanished since the last time that patch of sky had been observed. New asteroids, exploding stars, active galactic nuclei, supermassive black holes flaring at the centers of distant galaxies, variable stars pulsing in brightness. Every single one of those 800,000 events was flagged, cataloged, and sent to astronomers around the world within about 2 minutes of being detected. Read that again. 2 minutes. From light hitting a mirror in the Chilean mountains to a scientist's laptop anywhere on Earth. And that number, staggering as it already is, was only a test. Scientists overseeing the project have stated plainly that once the full survey ramps up to its intended capacity, the observatory is expected to generate as many as 7 million alerts every single night. 7 million every 24 hours for 10 years. Sit with that figure for a moment because it changes the entire nature of what astronomy even is. This is no longer a slow, patient science where a handful of discoveries trickle out each year to public fanfare. This is closer to an intelligence operation, a constant, high-volume stream of signals, most of it mundane, some of it strange, and a small fraction of it potentially unlike anything cataloged before. Somewhere buried inside millions of nightly alerts, the anomalies are already there. The only question is who finds them first and what they turn out to be. One astronomer working closely with the data, Stephen Smart of the University of Oxford, described the moment plainly. Everything that changed, appeared, or disappeared in that test observation was cataloged and triggered a signal. That sentence sounds simple. It is not. Because buried inside that description is an admission that the observatory does not know in advance what it is going to find. It is not confirming known objects. It is flagging the unknown automatically, at a scale no human team could process manually. And almost immediately, among the very first wave of alerts this system produced, astronomers began encountering something they didn't have a name for. They are calling them orphan transients. The term itself tells you almost everything about how uncomfortable this discovery is. A transient, in astronomy, is any object that brightens or changes suddenly. Most of the time, that means a supernova, a flaring black hole, or a pulsing star, something with a known category and a known explanation. An orphan transient is different. It is a sudden burst of light detected in the data that cannot be confidently linked to any known source. Not a galaxy, not a star, not a black hole, just a flash with no parent object identified, no known class of phenomenon it belongs to. One analyst working directly with the alert data described encountering exactly this scenario within days of the system going live. A burst of light with a near certain reliability score, meaning the detection was almost certainly real and not a glitch or artifact, and yet impossible to place into any existing astronomical category. The light was real. Its origin was not identifiable. Think about what that actually means. In an era where we assume science has already cataloged the sky's basic categories of behavior, a brand new telescope turned on for the first time, and within days, found something that doesn't fit any of the boxes we've built over a century of observation. If that were the only strange result from this observatory, it would already be remarkable. But it isn't the only one. Buried in the very first batch of asteroid discoveries from that June 2025 preview run, one object stood out enough to warrant its own dedicated scientific paper released in January 2026. Astronomers designated it 2025 MN45, an unremarkable sounding name for what turned out to be a deeply strange little world. It is a main belt asteroid sitting in the vast ring of rocky debris between Mars and Jupiter, roughly 7/10 of a kilometer across, small by asteroid standards, easy to overlook, except for one detail. When astronomers, led by researcher Sarah Greenstreet, measured how fast it was spinning, the number didn't make sense. The asteroid completes a full rotation once every 1.88 minutes. Let that sink in. Less than 2 minutes for an object hundreds of meters wide to spin completely around on its axis. That is the fastest rotation ever recorded for any asteroid of its size class. And here's where the real problem begins. Because most asteroids of this size are not solid rock. They are what scientists call rubble piles, loose collections of boulders and dust, held together by nothing more than their own weak gravity, like a pile of gravel floating in space, rather than a single carved stone. A rubble pile spinning that fast would not survive. Centrifugal force would simply fling it apart, scattering its pieces across the solar system in a matter of hours. And yet 2025 MN45 is still there, intact, spinning at a rate that should be physically destroying it, and it isn't. This is not chaos. This is a structural mystery with only one real explanation on the table. The object cannot be loose rubble. It has to be something far more solid, far more cohesive than the vast majority of its neighbors. Greenstreet's own working theory is almost as unsettling as the observation itself. that this might be a surviving fragment of the solid core of a planet that formed and then shattered in the earliest, most violent years of our solar system, more than 4.5 billion years ago, spinning wildly through space ever since, waiting for a camera powerful enough and fast enough to finally catch it in the act. And just when that seems like the strangest thing this telescope could possibly find, the story escalates again, this time towards something even more elusive. Stars that don't explode, they simply disappear. Astronomers call them failed supernovae. Under normal circumstances, when a massive star reaches the end of its life, it explodes outward in a supernova, one of the most violent and visible events in the universe, often bright enough to outshine an entire galaxy for weeks. But there's a stranger, quieter alternative theorized for decades and rarely confirmed. Some of the most massive stars in existence may skip the explosion entirely. Instead of blasting outward, they collapse straight inward, folding into a black hole so completely and so quickly that the star simply vanishes from the sky, with no explosion, no fireworks, nothing but absence where a point of light used to be. In February 2026, scientists identified a possible candidate for exactly this kind of event in the Andromeda Galaxy, our nearest large galactic neighbor. And this is precisely the kind of discovery the Rubin Observatory was built to catch, because its camera can detect events up to 100 times fainter than other sky surveys, meaning it can register a star's disappearance even when the explosion is really closer to silence. Now pause and connect these three threads together, because individually each one is strange, but together they reveal something bigger. An unclassified burst of light with no known source, an asteroid spinning fast enough to defy the physical rules that should govern its structure, a star vanishing into collapse rather than exploding outward. None of these are science fiction. Every one of them is a documented, published, real observation. But what unites them is this: they are all things